Assalamualaikum warahmatullahi wabarakatuh. The Honorable our lecturer, Ma'am Haryana Amalia SPD MPD. We are from Group 5. Today we would like to present the chapter 4. The material is about comprehension, understanding what we heard and read. Before that, let us introduce ourselves. My name is Novita Angreini and my partners' names are Muhammad Fadhil, Meldha Janneri Uatmia, and Nazhif Alfaqih Ahmad. So the first material is about the comprehension of sounds. That will be explained by me. The comprehension of sounds. Here is a simple example of how what we heard is influenced by psycholinguistic variables and is not just the accurate perceptions of the sequence of sounds or words that hit our ears. In one psycholinguistic experiment, a set of sentences was played to a group of listeners who were asked to write down the six words in each of the following sentences. The first is, it was found that the L was in the axle. The second one, it was found that the L was on the shoe. The third one, it was found that the L was on the orange. And the fourth, it was found that the L was on the table. Notice that in every case, the subjects heard L as the keywords in the sentence, but most of the subjects claimed they had heard a different word for each example specifically. The first is will for, the second is hill for, the third is pill for, and the fourth is meal for. The insertions of a different missing sound or phoneme to create a separate but appropriate L word in each sentence is called the phoneme restoration effect. Under these conditions, listeners do not accurately record what they heard. Rather, they report what they expected to hear from the context, even if it means they must add a sound that was never actually spoken at the beginning of the target word. Several simple but significant observations can be drawn from this sample of the early psycholinguistic research into the nature of comprehension. First of all, as just illustrated, people don't necessarily hear each of the words spoken to them. So, comprehension is not the passive recording of whatever is heard or seen. Listeners are not tape recorders, nor readers, video cameras. And the second, comprehension is strongly influenced by even the slightest of changes in discourse which the listener is attending to. In this example, except for the last word, each of these sentences is identical. And the last, comprehension is not a simple item-by-item analysis of words in a linear sequence. We don't read or hear the same way we count digits sequentially from 1 to 10. Listeners and readers process chunks of information and sometimes wait to make decisions on what is comprehended until much later in the sequence. In the course of everyday conversation, we don't hear vowels and consonants as isolated sounds. We can, with the help of machines, measure acoustic information extremely precisely. The P in the following English words is pronounced slightly differently depending on where it occurs in the word or what other sounds follow it. The initial P of pool is pronounced with puckered lips, but the same P in pill is spoken with the lips spread, and neither of these P sound quite like the P in spring. And the next slide. So what phonetic information do we employ as we listen to distinguish these names which are identical in pronunciation except for the initial consonant? Phoneticians have discovered that the main feature which English speakers attend to, albeit unconsciously, is the voice onset timing, or VOT, of the initial consonant. Okay, that is all from me. The next explanation will be explained by Meldha Janneri Uatmia. Meldha, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. My name is Meldha Janneri Uatmia. Well, I continue Novita explanations. Okay, let's start. There is a question. The question is, how do speakers of English or any language for that matter make these invariably difficult decisions about speech so rapidly and so accurately? It appears that the acquisitions of this phonetic ability cannot be completely explained only by exposure on or instruction in the language. In other words, native speakers do not acquire all of this acoustic information from direct experience, which language and parent caretakers do not provide implicit instructions on this matter. Even phonetics do not subject their children to hours of nursery training listening to minimal pairs like pie versus buy. Psycholinguistics have discovered through carefully experimentations that humans are actually born with the ability to focus in VOT differences in the speech sounds they hear, and they have proven that rather than perceiving VOT construct as continuum, people tend to categorize these mini phonetic differences in non-continual binary patterns. Next, categorical perceptions phenomenon. When subject hears sounds with a VOT of about 25 ms, about a halfway between B and P, they rarely judge the sound to be 50% voiceless and 50% voiced. Categorical perception is seemingly unique of human being and appears to quality as one aspect of universal grammar, or UG. The next about comprehensions of word sounds represents only a tiny and rather primitive of comprehensions. Obviously, the comprehensions of word is much more complex than the processing of phonemes, because even short one syllable word made up of the least several sounds, because these sounds may be written in different and inconsistent way in various language, because there are literally ranks up thousands of words in the vocabulary of any language, and most importantly of all because they convey meaning, and the comprehension of words is needed a very complex psycholinguistic process. Next, one model that psycholinguistics have adopted to account for the complex psycholinguistic process in parallel distribute processing, or PDP. And the last about the tip of the tongues, or TOT phenomenon. The phenomenon this happened because our long-term memory storage is better for recognition than for recall. We often know that we know a word so that even we cannot recall it from our memory, it is on the tip of our tongues, and we can instantly recognize the word when it's presented to us. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fadhil and I will explain the material about the comprehension of sentences. Comprehension involves much more than decoding of sounds, letters, and lexical meanings. It also involves the untangling of the semantics of the sentences. Chomsky's models claim that all sentences were generated from a phrase structure skeleton which was then fleshed out into everyday utterances by a series of transformational rules, hence the term transformational generative grammar. Using this model, psycholinguists immediately became interested in comparing the number of transformations used to derive sentences and the relative difficulty native speakers experienced in comprehending them. They based early experiments on sentences pairs like the following. Number 1. The dog is chasing the cat. Number 2. Is not the cat being chased by the dog? Okay. From the standpoint of TG grammar, number 2 is much more complex than number 1. Not simply because it contains two more words, and, the, and by, but because not unlike number 1, which corresponds with the underlying PS sentence, number 2 has undergone 3 transformational changes. It has been transformed into a negative passive interrogative sentence. Accepting this linguist analysis for the moment, it's easy to see why psycholinguists thought that pairs of sentences like this might offer insight into the comprehension process. It seems logical that simple kernel sentences like number 1 are easier to comprehend and remember than complex sentences like number 2. Okay, next. Psycholinguists who first experiment with this hypothesis call it the derivational theory of complexity, or DTC. For example, subjects were given a random assortment of sentences like the following and were then asked to recall both the sentence they had just heard and a string of words spoken immediately after the sentence. For the example number 3, the dog is chasing the cat. Bus, green, chair, apple, and etc. Number 4, the dog is not chasing the cat. The car, blue, sofa, beer, and etc. Number 5, is the cat being chased by the dog? Bike, pink, table, beach, and etc. Number 6, is not the cat being chased by the dog? Train, yellow, stole, grape, and etc. Researchers hypothesized that since working memory constrains the amount of new linguistic information we hear, and because each sentence got more and more complicated in a very quantifiable way, the subjects would remember fewer and fewer words following each sentence. That is based on the DTC. It was claimed that number 4 was number 3, plus an additional transformation, the negative. Number 5 was number 3, plus 2 additional transformation, the passive and the interrogative. And number 4 was number 3, with 3 additional transformations, the negative, the passive, and the interrogative. Accordingly, it was hypothesized that for sentences like number 3, subjects will remember several of the words following the initial sentence, perhaps around 6, but that for each successive sentence, subjects will remember one fewer words on the list because their working memory would be taxed by additional transformations. Initial experiments like this based on the DTC show a very broad confirmation of the hypothesis. The number of words remembered at the end of each sentence seemed to correlate inversely with the number of transformations, presumably.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nazhif Ahmad. I will continue explaining the material that I have explained by Muhammad Fadhil. Well, another series of experiments demonstrated that semantics, rather than syntax, seemed to be the main determinant of comprehension difficulty. Thus, in the examples below, number 7 and 8, a passive sentence like number 7 took less time to process than active sentences like number 8 because they were semantically more plausible. In fact, sentences like number 8 tended to be remembered as number 7 because subjects retained a rough memory of the word order but were reluctant to admit that they heard the highly impossible event described by number 8, even though it was an active sentence. Instead, they were quick to claim what they actually heard was the reputedly more difficult but vastly more plausible passive counterpart, number 7. Contrast this solitary grammatical change with the 4 operations that are needed to change an active sentence like number 9 into its passive equivalent, number 10. First, the subject and object are reversed. Second, the preposition by is inserted before the original subject. Third, the verb be is introduced in the correct tense. And the last, fourth, the main verb is converted into its past participle form. Despite all of the changes specification entails, it still seems that negative sentences take more time to comprehend and they are more difficult to remember than passives, a finding that further undermines the hypothesis that the DTC plays a significant role in comprehension. This initial finding led to some further psycholinguistic inquiry into the innate difficulty of negatives and showed that negation, especially double or triple negation, is exceedingly difficult to comprehend, despite the fact that grammatically it is a simple structure in English. We can see this finding in number 11. And then notice that in sentences number 12 and 14, the words immediately preceding the target sound b are ambiguous. Men can drill by using an instrument or by rehearsing marching formations, and straw can refer either to dried grass or to a tube used for sipping liquids. In contrast, sentences number 13 and 15 do not use ambiguous words immediately before the target phoneme. Sure enough, the subjects took several tens of milliseconds longer to hit the button when they heard the boo for sentences number 12 and sentences number 14, most probably because of the ambiguity of the words drill and straw, which immediately preceded the target sounds. Subjects were significantly faster in responding to the b sound for sentence number 13 and 15, presumably because they did not have no access to different meanings for march and oaths, the words which they heard just before the target phoneme. The general tendency for all listeners and readers to make increasingly confident predictions about the meaning of a sentence as it progresses is well attested in psycholinguistics and is colorfully called garden pathing. One well-documented example of this phenomenon is the way comprehension is temporarily impeded when the listener or reader meanders down the wrong garden path in comprehending a string of words. Researchers asked subjects to read sentences like number 16 while they measured their rapid eye movement scanning the next using specially designed contact lenses. Well, that's all our presentation today. Thank you very much for watching and thank you for your great attention. From our presentation, from our explanation, anybody would like to ask? Well, we are from group 5. We do apologize for our mistakes in explaining the material. And the last I say, wassalamualaikum warahmatullahi wabarakatuh.